Vectors in maths are a bit different from vectors in physics, especially when we are dealing with shapes. Because when we draw vector triangle, when we used to draw vector triangle in physics, what we noticed that we use triangle laws, or we use triangle formulae to find a resultant vector. Here in maths problems, when we would have vector shapes like triangles, we would be drawing or just making to find a resultant vector. We will directly write the sum of two vectors as like a plus b if the vectors are a and b. So let's start with vectors. So vectors, we will learn about how vector is represented. We just have discussed it, that a Cartesian coordinate plane or Cartesian coordinate system is simple xy plane, that where we draw some x-axis and y-axis. So if we are drawing x-axis and y-axis, and we do know that on the other side is it would be negative x-axis on the left, and downwards it would be negative y-axis. So if we just draw a point here, this point would have some coordinate. Let's say its x value is x value, and y value we just enclose that in brackets. It becomes the coordinates, right? So this is origin 0. So if we have some origin reference point and we draw a straight line from 0 to O, this is our position vector for that point P, right? So this one we have discussed. We will be using some basic algebra that we have discussed, addition and subtraction of vectors. Now in this case today, what we are going to solve some of the challenging questions. We will be solving from vector triangles, right? So we will be checking out head to tail rule. There would be two vectors, like let's say a vector A and vector B is drawn in such a way that the head of A is touching the tail of B. So it's a head to tail rule. We will see a third vector in the sense that third vector is from the first, you are considering first as a vector and the second as b vector. So the third vector from a to b, or joining a to b, is the sum of these vectors a plus b. This is the resultant vector. That's what we do not do in physics, because in physics we are usually given with vectors magnitude, like let's say this is 2 Newton and let's say this is 3 Newton, right? So they were the forces, actual quantities. Now we are not dealing with actual quantities. We would have diagrams, triangles, vector shapes, and vectors are just denoted by some small alphabets a, b, c, or any. But what is how we can identify them? It would be like a bold letter or a letter and an arrowhead over it. It becomes a vector, right? So that's what which we did. We discussed as well that the sum of two vectors drawn in such a way that they are making a shape is a triangle. So we will see which two vectors are drawn in such a way that the head and tail are touching of those two. So the head of A and the tail of B is touching. It's very clear that A plus B we have to do, and it would be the third side of the triangle. It would be the third vector, that is A plus B, right? So the procedure or the things are very same that we usually do in physics. We draw vectors, we make vector triangle, and we say that the resultant is from the first to the second, and this is resultant is the sum of vectors. So we are just directly doing sum a plus b. Now let's proceed. We will see some questions as well. Also, the other thing is Pythagoras theorem we should be using. Why we would be using that? We have discussed that a vector is represent. Yes, correct. So we would find the magnitude because any vector pxy, a position vector from 0 to x, will have a movement, horizontal movement as well, and vertical movement as well. So if we want to find the length of OP vector, from O to P is a vector, but what is its length? This length would be the magnitude. So it makes a right angle triangle when we just when we when we traced the horizontal movement and the vertical movement to reach this point P, we at the end got a right angle triangle. This is the X movement, this is the Y movement. So using Pythagoras theorem, the hypotenuse square equals to the sum of squares of other two sides of this triangle. So if we take the square root, this hypotenuse would be the square root of the sum of the squares of other two sides, correct? It would be very easy to find the magnitude because here in mathematics, the vectors that we would be just dealing with are actually given like OP vector is given like a column vector. So vectors are written in column. It would have x value and y value. For example, this x value is 2, y value is 3. So OP vector becomes OP vector, sorry, OP vector then becomes, let me write here, OP vector then becomes 2 and 3. So we will be doing this, and if we have another vector OQ vector, let's say it's some other position vector drawn on the Cartesian coordinate axis, these x y axis actually. So if it's some other position vector of Q and it may have any coordinates, let's say um, -1 and 2 or -1 and 5, we can add these two vectors. By adding, we will just add their, at the end write we will write correct. So we will write in the form of column. It would be OP plus OQ, 2 and 3 is OP, plus OQ is -1 and 5. So it would be a direct sum of their, the at the end we just have to write it in the form of column. So it would be direct sum of x with x value, 2 plus into -1 is 2 minus 1, 3 plus 5 is 3 plus 5, and their sum then becomes, their sum then becomes 1 and 8. So we will see this. Let's move to the next slides. This is what a brief overview and the knowledge that we need to start the vectors in maths. And we will represent vectors in columns. We would have a vector with x and y value because we x and y, it could be z as well, there could be three values as well, but we are actually uh, doing or drawing vectors in two dimension. I mean in just x and y axis. Z axis is not involved at this level. So we will that's why we have just x and y value, and then the magnitude we have discussed, then head to tail rule. This is really important. For today we will be just doing some challenging questions from here. Each time we'll consider a triangle and we will see in the triangle which two vectors are drawn in such a way that the head and tails are touching. So this is vector A, this is vector B. Clearly, A and B are drawn in such a way that the head and tail of first and second are touching. So consider this is the first one, consider this is the second one. The third vector or the third side in that triangle will be the vector sum of A and B. That's how we draw the resultant. So this third will be drawn in such a way that it would be pointing from A to B, so from pointing from 1 to 2, and it would be the sum of 1 and 2. 1 plus 2, 2 it means A plus B. Now similarly, if we consider this triangle and we find what should be the vector AB, we have to check that which two vectors are drawn in such a way that the head and tail are touching. So OA vector, which is small a, and AB vector are drawn in such a way that their head and tail are touching at this point. O's head is pointing towards the coordinate A, sorry, A's head is pointing toward the coordinate A, and the tail from of AB is touching the A vector. So the sum of this vector OA, let me write here, the sum of vector OA plus AB will be equal to the third vector, which is pointing from the first to the second, right? This is the first, this is the second, because these two are the vectors which are drawn in such a way that the head and tail are touching, correct? So the third vector is drawn in such a way that it would be pointing from 1 to 2. So this OB is the sum of OA plus AB. Now we want to find AB. So OA is a simple operation. We take, just consider it as an equation. So OA move to the other side of equation. It will be OB minus OA, and OB and OA are position vectors of A and B. A and B were again some points in the Cartesian coordinate system. They would be given, so we will find, and their vectors are actually given, the position vectors. OA is small a and OB is small b, so we will just directly do OB is B and OA is A, so vector AB is B minus A, right? So in maths we are doing this only, not actually having the magnitude, especially in vector shapes, in vector triangles in maths. We just be having like vectors denoted with some small alphabet, some bold letters, and we will be just doing a direct sum like a plus b, small a plus b, p plus q, n plus m, and like that. Now we will move to some questions. Let me raise this and move to a bit like more slides to overview some of the basics, and then we will move to the questions. This is what the vector means in real life context. I mean, we see a lot of examples where we need direction. So one of the most basic example is like this distance. We want to go from A to B. So if we follow any random path, this blue line, it's quite a random path, no specified direction. We would have only the magnitude, I mean the how much path length you have moved to reach B when you start from A. So how much path length, it's a magnitude. How much is the quantity's magnitude that you have to tell. But if you follow red line from A to B, you definitely are going in this way, that it has a specific direction. So a red line is a vector and the blue line is the scalar. And in physics or in daily life examples, we call them distance and displacements. Clearly the red line displacement has the direction. The blue line is any random direction we are moving to reach B. Okay, again, column vectors, how do we represent? I'll be sending you these slides. How do we represent them? And we just how we will write a column vector, or how we will write in the form of, how we will write a vector in the form of column or in column form if we have some movements, 3 units right, 2 units up, So it's 3 units right is the x movement, horizontal movement, and 2 units up is the vertical movement, y movement. So we will write x and y in a column. It becomes a vector. Similarly, 4 units left is negative x, right? And 5 units down is negative y. So it's negative 4 and negative 5 it will be. And how do we add the vectors? We have discussed. If there are two vectors that should be written in the form of column and we are adding them, so it means we add x value of the first vector with the x value of the second and y value of the first with the y value of the second. The result becomes the sum of these two vectors. If you are subtracting, we'll do the same. Subtract the x value of the first with the x value of the second and y value with the y value of the second, and the result is the subtraction of these two vectors. Scalar multiplication, k would be multiplied with both these uh, components of the vector, both these values, x value and y values. So here are examples of addition, subtraction, and multiplication. 2 plus 3 is 5, so the result is 5. Minus 1 plus 4 is 3, the result is 3. And here as well for subtraction and for multiplication. How do we find the magnitude? We have discussed a vector has the x movement and y movement. If we trace the x and y movement to reach this point, we would have a right angle triangle. So the magnitude will be, by using Pythagoras theorem, it would be the square root of the sum of squares of x and y values. Head to tail rule, vectors in shapes, we would see mostly and making vector triangles in questions. So let's now move to the questions. These are again all the basics, position vector we have discussed. These questions we have discussed, but let me answer this quickly again, and if you can, we have answered them as well last time. So 3 times fg vector is 8 and minus 3, so 3 times 8 and minus 3, it'll be 3 times 8, which is 24, and 3 times minus 3, which is minus 9. So the answer is 24 and 9, and the questions were just, we have 1 mark, so we can directly write the answer as well. And even if you're doing 1 step extra, it's still okay, because the question says find, it does not say write. When it say write, then and it has a 1 mark as well, so you directly write the answer. 8 minus 3 plus minus 12, 35. Can you hear me, Sufyan? What would be the answer of this? Can you directly tell me? Plus 32. Great. And to find the coordinates of the point G, we need to consider because we have discussed that the G and H are all those vectors uh, which coordinates we are given with f, right? So we will be thinking that f vector, f is a point which is this point 1 and minus 4. There would be somewhere a point G as well, don't know where. Let's draw randomly here. It may have any coordinates x and y. So if we are drawing a vector from O to F and then F to G, all right, O to F and then F to G, again a vector triangle, then O to G vector will be the sum of these two vectors, correct? So we will just make a vector triangle for these, or consider if these are vector triangles. To find the coordinates of G, you will consider OG is a vector which is F OF plus FG, and then we have OF vector, because F point is given. So from O to F, O is the origin, 0, 0. O to F vector will be 1 and minus 4. 1 and minus 4 plus Fg vector is also given, 8 and minus 3. So it will be just a simple sum, and you'll find the coordinates of G point, because OG vector is x and y. So x, y values are the coordinates of G point. It'll be 1 plus 8, which is 9, minus 4 minus 3, which is minus 7. So 9 and minus 7. Quite, these are very basic questions. I will definitely now move to the tough one. The magnitude of GH is again square root of the sum of squares of. Very good. And we will do one more step, find the exact answer, right? So one more step and then write the exact answer, because it's a 2 mark question, so you can do 2 or 3 steps even. These are the questions which are bit more challenging, and they actually involve the shapes, vector shapes. So if we have to do them, we just need to make several triangles to do them. So if, let's say, if the question reads, this is this is from paper 2024, paper 2. Okay, but this is challenging in paper 2 as well. Not that much challenging, but these kind of questions are usually challenging, where we have shapes and we have vectors. So in the diagram, OA vector, which is A, small a, OB vector, which is B, OB vector, which is B, and some informations are given. AK ratio KB is 2 ratio 1. AK ratio KB is 2 ratio 1. It means if the whole line from A to B, yeah, if the whole line A to B has total 3 units, 3 centimeter. Correct, correct. So if it has 3 units or 3 parts from A to B, the 2 parts are with AK and 1 part is with KB. Correct. So it means from this information we can also write that vector AK is 2 by 3 of the vector AB, because we can consider a vector triangle OAB and find AB in terms of A and B, small a and B, and then we can write AK as well in terms of small a and B. Okay, so this was the information. Now from the given information we can write this. The next is OK equals KC. So this one, OK is also equal. Yeah, I can also write that 2AK, 2AK equals AB. No. If I write twice the AK, or I should write actually what I should write is BK is half of AK, or KB, sorry, or vector K to B is half of the vector A to K. Okay, from this information I can write that this thing. So 2KB, twice you do twice the KB, it will be equal to AK. Basically this whole line from A to B has 3 parts. 2 parts go with, 2/3 go with AK, 2/3 of the AB, it's very clear, 2/3 of the AB, 2/3 of the AB is equal to AK, and 1/3 of the AB is equal to KB. Correct. It means like that. Now, what actually we have to find AC. So vector from A to C, from A to C we have to find. If we want to find from A to C, we can have several chances. We can write first AK, what is AK, and then KC. We will see that in this triangle AKC, in this triangle, if we have vector AK and KC, the sum of AK and KC will be equal to AC because head to tail rule. This is the first vector, this is the second vector. So head of the first is touching the tail of the second, and the resultant means their sum is drawn in such a way that it starts from first and points toward the second. So it points from first to the second. This is the resultant. The third side is always resultant when you just when you just find out which head and which tail is touching, and those two are the sum, and the third would definitely be their sum resultant, I mean. So it's it's clear that to find AC, we can write in the hint that AC is actually AC is actually AK AK plus KC. Okay. So we need to find vector AK and KC in terms of small a and b. It's very easy to find vector AK in terms of a and b, small a and b. You need to find vector AB, because if you find AB, two-thirds of AB is AK. So to find AB, it's very easy. You consider, let me draw it here separately. You consider the triangle OBA, okay? And in that triangle OBA, vector OA is small a, vector OB is small b, and the third vector AB is this vector. AB is pointing from A to B. You have to find AB. So see which two vectors are drawn in such a way that the head and tail are touching. OA vector and AB vector, their sum will be equal to this third vector OB. So OB, I would write, sorry, OA plus OB is actually OA plus AB, sorry, is actually equal to OB. Now OA goes to the other side, you find AB. AB is actually equal to OB minus OA, which is OB is small b and minus OA is small a. You have found AB in terms of small a and small b, correct? You can find AK in terms of small a and small b because AK is two-thirds of AB, right? So AK is actually equal to two-thirds of AB. AB is B minus A. B minus A, right? One thing is done. Now only the one thing is left. Find KC as well. To find I'm sorry. Okay. So to find to find to find KC, we can consider or find the vector OK. Vector OK and vector KC will be equal. Why they will be equal? Because OK and KC are equal. If you point from O to K and then K to C, you draw two vectors. their lengths are equal, whatever their magnitude will be, their directions are same as well, so the vectors would be exactly same as well. Correct? Go from A to K and then K to C. The direction stays the same as well as their length. O to K and KC are equal. So let's find what is OK vector, because you can consider this triangle OKA. Correct? You have OA and AK. The sum of OA and AK will be OK, because now let me draw it actually here. The first vector is from O to A, okay? Then you go from A to K. You clearly see that you go from O to A and then A to K, the head and tails are touching. Their sum will be equal to O to K. So OK is actually equal to OA plus AK, and you just write the values. OA small a plus 2 by 3, AK is 2 by 3 of B minus A. We open the brackets. Can you open the brackets and solve for A? What solve for OK? A terms we have to add together, right? So it will be A minus 2 by 3A, correct? Because this A and this is 2 by 3 times minus A, so minus 2 by 3A plus 2 by 3. I'm sorry, let me write it down. A okay is A minus 2 by 3A. How much is A minus 2 by 3A? Correct. Plus 2 by 3B. So OK is same as KC. We will just add these two and we'll get AC, because it's clear that to find AC we need to consider a triangle AKC. So it's 1 over 3A plus 2 over 3B, right? And we have found OK. Now OK and KC, since OK is same as KC, so AC is equal to AK plus KC. AK is 2 by 3 of B minus A plus OK, KC is same as OK, 1 by 3A plus 2 by 3B. So we will just add the like terms together, A terms and B terms. 2 by 3B and 2 by 3B, it becomes 4 by 3B, right? And minus 2 by 3A plus 1 by 3A. So we'll see it's 1 by 3A minus 2 by 3A and plus 2 by 3B plus 2 by 3B. It will be 1 by 3, 1 minus 2 is minus 1 by 3A plus 2 plus 2 is 4 by 3B. That is the answer, right? So what we have done is consider each time triangles, triangles, and triangles, right? So we have done what is actually considered triangles, triangles, triangles. समझ आई? So sorry फिर से let's see again. So OM is given, ON is given as well. What do we have to find? Yes. Or what we can do is we can find NM, right? We can find MN or NM, because we need to find OR na. So we will consider either this triangle, this one, correct, or either this one. To consider those two triangles, one of those two triangles, you need this side for considering the first one, this side MR, or you need this side NR. But from the given information that R is the point on MN such that MR ratio RN, if you go from M to R and then N to R to N, the three parts are with M to R and two parts are with R to N. Okay, so it means total parts from M to N are five parts. Any of like vector MR or Rn will have those ratio over total, correct? So if you consider MR, let's say MR is how much of total Mn? Mr is how much of Mn? Mn is from M to N, I mean the whole line, or divides Mn into these ratio 3 ratio 2. It means Mr is 3 by 5th, 3 over 5th of the total Mn. I mean 3 over 5th of the total is Mr. 2 over 5th of the total Mn is Rn. So you can find Mr instead, and then we can consider the upper triangle OMR to find OR, correct? So this is from the given information. Now things become very easy. What you need now, you yes. Yeah, yeah, you can what you can do is, let's say, you can consider this triangle, because you have to find OR. It must always be making a triangle to find OR. If you want to find OR, this is from O to R, you have to reach either this path, you go from O to M first and then M to R, it makes a triangle. Or you can consider this path, you have to go from O to N first and then N to R. I have chosen the MR one. Either we can choose, both are easy to solve, but always the rule is, see which triangle you are making and how the head to tail rule is obeyed. Now if you are tracing this triangle to find OR, you go from O to M and then M to R, so OM plus MR will be equal to OR. Clear? There are three sides, so these two sides are joined in such a way that head and tail are touching. O to M plus M to R, I mean OM vector. The hint is OR vector you can get once you go from O to M. So OM vector plus then you go from M to R. Okay, you can find this. Okay, now now let's do this one. We we need to find MR because we have OM is small a. We need to find MR. To find MR, we need to find MN, correct? MN, because MR is 3 by 5 of MN. We will put the value of MN. It will give us what is MR. So let's find MN. MN, to find MN, you need to consider another triangle, obviously. Another triangle we can consider is OMN. OM and N. If you consider directly this one, you will directly get the value of Mn in terms of A and B, because two sides are A and B. The third side you can find by the vector sum. So you are having this triangle Mn vector, OM vector. Both are just drawn in such a way that the head and tail are touching, and on is such a way that it is from the first to the second. So om plus mn is equal to on. From here I'll write what mn is. Mn is equal to on minus om. On is b, om is a, so mn is b minus a, correct? Can we find mr now? Yes. Mr is 3 by 5 of mn, so it will be equal to 3 by 5 of b minus a. Now can we find OR and show that or see that this would be equal to this? Yes. OR, from the hint it's clear that OM plus MR. What is OM? OM is small a plus MR. MR is MR is this one which we have find 3 by 5 of b minus a. Now let's do this. It'll be a terms together. We have to write a plus minus minus 3 by 5 of a, then plus 3 by 5 of b, sorry, 3 by 5 of b. So a is 1a minus 3 by 5a. It will be 5 minus 3 by 5a, right? 5 minus 3 is 2, so it will be 2 by 5a plus, no, this would be 5 now. If we write it 1, so we have to make it 5 over 5 as 1, correct? 5 over 5, so it will be 5 minus 3 in the numerator divided by 5, so which is gonna be 2 by 5 a plus 3 by 5 b, right? So this is all like what actually we are doing is each time we are making a vector triangle and the things become very easy. You need to trace OR kind of, sorry, फिर से बताओ. Each time we are making triangle, it's okay. Tomorrow we'll practice a bit more because these are challenging question, paper 4 questions. So these are not done very quickly because these are vector shapes questions. So we have to practice a bit and see which triangle is like we need to consider. But the rule is very small, very easy. Sorry, the rule is very straight that you have to consider a vector triangle and you have to sum those two sides which are drawn in such a way in that triangle that the head and tail are touching. The sum of these two will be equal to the third one. MOM plus MR will be equal to OR, definitely. Right? So then you find, and then you need MR as well. If you need MR, you have to have MN because MN only is the side you can find in terms of A and B first by considering OMN triangle. So we need to like think smartly that which triangle we have to consider while solving these questions. These are challenging one most of the time when we are solving in exam papers or when students are solving. So they get might like little bit confused, but when we have a good practice of like vectors, addition, and triangles that we need to consider, we will just do them quickly. I think let's stop here and continue tomorrow. And I'll send you this worksheet. You have to try this question third, okay? These are the challenging questions as we have sent. So you have to try this.